Today we are going to see necessity of coding, or basically what is a code. Code is nothing but it is a group of symbols which may be represented by numbers or letters. These codes are nothing but it is a representation of information or data in a particular format. We say that any number or letter is being encoded, means which is coded. We are assigning some specific group of symbols to it to represent some information or data. Followed? So this group of symbol is called as code. Now why there is a need of coding? Now as we know that we have already seen that computer or a processor, a machine understands language of ones and zeros. So this binary data which is in the form of 1 and 0, if you represent a long string of binary code, binary data, it is in the form of 1 and 0. But is it easy to remember so many ones and zeros? No. So we have already seen that we can represent any information that is in form of either 4-bit, we call it as a nibble, 8-bit, we call it as a byte, or we can represent it with 10-bit, 16-bit, 20-bit, 50-bit, 100-bit and till n-bit. Now this number of bits is what actually we group this, we can group this bit of the binary number into smaller parts. Followed? So that why but grouping is necessary? Because grouping, when you group them, it will be group them and give a code, that is encode it by grouping either with 4-bit, 8-bit and so on. Then this group will be one data, second data will be the second group of number. So this becomes easier in representation, storing, transmitting the information. Followed? So now this representation of this binary data, why it is necessary? Because it is easier to understand, represent, as I told you, even to store in the memory, so that we can assign specific memory size to this. But then this group of numbers will be utilized by whom? This is actually the binary number is used by the machine to process the data. So when we talk about the user, when we user are working with the machine, we understand decimal number, but the machine understands the binary number, right? So then so each character which we will enter has to be represented by some binary code, that is some group of bit. Followed? So this is necessity of coding for easiness of understanding, representation, storing, transmitting. Now this binary code we have already seen, or a binary bit. Each binary bit will have some weight assigned to it. That is, we have seen what is the weight assigned starting from the LSB. Each digit will be assigned with the weight of power of that particular number. So when it is a binary number, what will be the weight? The weight assigned will be 2 raised to 0, 2 raised to 1, 2 raised to 2 and so on. Clear? So this way the weights are assigned to this binary number. Now when we represent any, say any code is of 4-bit. So what is the, how many positions will have? So 4 positions. So what will be the weight assigned? 2 raised to 0, 2 raised to 1, 2 raised to 2 and 2 raised to 3. Now this number of bits also decides that how many different combinations we can have. So like suppose 4-bit will have, then how many combinations will have? 2 raised to 4. So there are 4 digits. So 2 raised to 4 means that is equal to 16. So total 0 to 15 state, that is total 16 states can be made available, or this way different combination codes can be made available by any user or the machine can have. Followed? If the machine processes a 4-bit data at a time, it will go on increasing if the number of bits go on increasing. If you have a 8-bit data, what will be the number of combination? 2 raised to 8. If we have a, that will be 256 combination. If we have a 16-bit data, that will be 655 3-6 combination. So this also decides, this grouping of the bits also decides what the number of combinations we can have, of number of events we can have. Followed, because each code will represent, each group of it will represent some different information. So we have seen in the second lecture, that is the decimal equivalent we have seen for the given binary number of a chart we have shown on the slide. So that was a 4-bit representation, but how many combinations we had? 0 to 15, that is total 16 combination, right? So this way we can decide from this number of bits how many combinations we are going to have. Now this combinations, what we are going to have, it is actually a digital input, data input to a machine. So it can have a combination of control characters, alphabets, punctuation marks. Then different characters are represented by this group of bits. Followed. So it can be anything, as we just now I told you, it is a character set, or we can call it as a character code, which represents alphabets or some numbers or special functions which we have on a keyboard or some other characters. Now this binary coding schemes are used in computer to represent data internally, which is used by the machine to process the data. But when the data is processed by the machine, that is the processor, the computer, it will be given to the outside world. So now when we want to read it, we will understand which language? We will understand the decimal language, isn't it? We work with the decimal language. We understand more, we are more comfortable with decimal. So then we have to again decode the data or the code, right? So this is how the coding works. Now a group of bits, maybe 8-bit, it is used to represent a symbol, that is a string of symbols. Followed, it can represent anything. Now accordingly, then they are divided into 2 types. This coding is divided into 2 types in general, but there are different other forms also. So weighted code like 8421, when you represent a 4-bit data, that is with the power of 2 raised to 0, 2 raised to 1, 2 raised to 2 and 2 raised to 4. So it becomes a 8421 code which has unique weight assigned to it from the LSB to MSB, right? Then there are coding like Ascii code. Ascii code, many of them have heard about it. The keyboard which we use in the computer is and called as Ascii keyboard. Why? Because the characters like ABCD 1 2 3 or control character or backslash, whatever you have, each character is assigned a 7-bit code to it, and that code is framed by international standard which is called as Ascii keyboard. That is American Standard Code for Information Interchange. So it is a 7-bit code, remember that. But 7-bit code means how many combinations we can have, how many different symbols we can represent here. 2 raised to 7. 2 raised to 7 is 128 total different characters we can encode. But nowadays keyboard, you find that there are many different other control keys. Then what to do? We go for the next type of code, that is EBCDIC code, Extended Binary Coded Decimal Information Interchange. So when you want to increase the number of characters, then means we have to increase what number of bits. So 2 raised to 8 means it will become 256 characters here we can code. So then we use this EBCDIC code. So according to the need, the coding use of the different codes goes on changing, followed according to the application which we require with the help of the computing device. Then gray code. Gray code is one type of code which is a unweighted code. It is with the binary number but not a weighted positional weight like we saw in case of this 8421 code, which is also called as BCD code. So gray code is basically used to encode any this what you call in instrumentation. Basically it is used in instrumentation industry. Then the next code is XS3 code. XS3 code is also very important. It is called as self-complementary code. So this way there are different types of code according to the applications used in this logic circuit. We use this different coding techniques. Apart from this, now when you transmit the information over long distance, and nowadays everything is digitized. Now you take your mobile which you are using right now, or you take your laptop. So whatever internet facility you have, this networking, the data is actually transmitted over long distance, isn't it? But how it is possible? Again, due to the digital device, so obviously the data will be in digital form. So when the data is transmitted over long distance, the data has to be transmitted, stored, then it is being received. Followed? So now in this process, it may happen that suppose one bit of data, say 1 becomes 0 or 0 becomes 1, that is actually what? That is a corruption has occurred, means some data is lost in between. But this is not accepted because this will change your information itself. So there you need some codes which will detect the information and correct the information. So those are called as error detection and correction codes. Getting? So this way we use many type of coding which is regularly used with our all digital system in day-to-day life. Whatever digital system we use, everything requires coding because we work with the binary numbers. For our easiness of understanding representation, we use this code, and hence there is a necessity of coding. Now for example, you have seen in movies when you see that some war is going on. So what does this defense personnel they do? They talk on the wireless by some code words, using some code words. Why? Because any enemy, they should not track the place where you are located or what is the name of the person who is communicating, right? So you use code words. Then even you have to talk behind your teacher, something you have to talk about that teacher. What you all do? You use that code word for your teacher. Why? Because you want to talk about the teacher, but you can't take the name, you have to hide her name, isn't it? Her or his name. So then that is what is use of code words. So understand it, what is the necessity of representation of different types of codes and use of this code in your computing device.